welcome to Graph Solution. Today, we want to be looking at dimension. In physics, we are in episode 5. And let us look at dimension. What do we mean by dimension? Dimension is to understand the length, the mass, and the time in fundamental quantity and derived quantity. Is to understand what? The length, the mass, and the time in derived quantity. Now, what do we mean by this? This one represents, in dimension, we write length as L, mass as capital M, and T as what? Time. Now, this is what we call dimension. Now, what do we mean by dimension? Now, remember, I told you in a fundamental quantity that anytime you see a question like this, that when we see length can be height, can be breadth, can be distance, can be displacement. Remember, all of them I mentioned it in what? In what? Derived quantity and fundamental quantity. Now, anytime we see example now, let's look at this, like volume. When we have a volume like this, volume. What is volume? Distance. Volume is length times breadth times what? Time times height. We use the breadth, the what? The breadth, the length, the breadth, and the what? The height. Now, in this, in what? Length represents what? L. Breadth represents L. Height represents L. All of them, they have L times L times L. Now they become L cube. The dimensions of volume now become what? L cube. Now let's look at area. The area is length times breadth. The length times what? Breadth. Now the area. Now, the length represents L, breadth represents L, become L3. Now, in area is, when we talk about the area, now, the velocity, the speed equal to what? Speed is distance all over time. What is distance? I give you L. Time represents what? Capital T in dimension. We don't use meter or any other thing. We use this one. It becomes what? L. This one, because it's down, the T. This one, because down, will be minus 1. This one is T1. This one is T1. That's why it is 1. And because it's down, that's why it's minus. Notice that. Now, velocity. Velocity equal to what? Displacement all over what? Time. What's the displacement? Our displacement, distance represents what? The same thing. Time, T, it become what? The same thing. L, T minus 1. Anytime that is down, it will always be minus. If it is 2 that is here, it become what? Minus what? 2. Notice that, but this one is not anything. It's one just ordinary 1. Now, the next one, acceleration. Acceleration. What is acceleration? Acceleration is what? Acceleration represents volume all over time. Remember, what is the volume? The dimension of volume is what? L all over T. The dimension of volume is L over T. You have time again down. T. Remember, we can now write L all over T. This one is only 1 T. This one is fraction. This one is turned into fraction all over 1. Now, this is the division line. Now, we have a division T all over 1. If you want to turn it into times, it becomes L all over T times T equal to 1 all over what? T. Become L all over T squared. Now, it becomes what? L T minus 2. That's the dimension of what? The dimension of acceleration now is what? L all over 2. What are the dimension? Dimension of force. Dimension of force. Now, what is the dimension of force? The dimension of force will be F. The dimension of force is mass times acceleration. That's the dimension of force. Now, this one, mass is what? What is mass? Is what? A mass will represent capital M. And remember, what is acceleration? The dimension of acceleration is what? Times LT minus what? 2. Multiply it now to what? N L T minus what? Minus 2. That's the answer. Now, another one is energy. Energy or work. They are the same. Is what? Force times what? Distance. Remember, what is the dimension of distance? Is this. The dimension of distance is what? The dimension of force is what? This. And times what? Distance. What is distance now? L. You will now be what? Force is what? M. L T minus 2 times the distance being L. How many L now? L times L become what? N L squared and T minus 2. You see now? Let's move to the next one and let us work on work. The work is, what's work? Work is energy all over time. Now, all over what? Time. Notice that. Now, the energy is what? Is M L T minus what? 2. All over what? All over. What is our time? The time is what? Capital T. You now be, you know, because this one is down. I've told you several times that when it is down, the minus, it now become M L 2 and T minus what? Minus 2. Because this one is down, it will be T minus what? 1. 1 is down. When you now multiply this one together, it become M L 2 T L 3. This one is 2. You add this with this one, become what? T. That's the dimension of what? Energy. This is how the way the dimension is. But in JAMB, they normally put it in a different dimension. Like, I want you to keep this one in your mind that you can able to understand. In JAMB, when they bring it, sometimes they will say, find the value of x, find the value of x and y and z. Find the value of x, y, and z. Now, they will give you that, okay, if the energy equal to, they will give you the energy. If the energy equal to M, L, and T, M, X, T, L, T, Y, and T minus what? 3. Minus what? Z. They will give you like this. They now said, they will say that find the value of x. If this equal to this, how can we find this? Now, this one is talking about what? Dimension. Now, what is the dimension of what? What is the dimension? They give us remember, they give us L as Y, T as Z. They now say that to find the dimension. Said, if the energy is this, find the dimension of what? X, Y, and Z. How can we find this? If you can able to get the dimension of what? Energy, it is easy to get this one. Now, what is the dimension of energy? Energy equal to what? The dimension of energy is what? Is this. Now, the dimension of energy is what? This is what? M L2 T minus what? 3. That's the dimension of energy. You now write the energy N to t minus 3 equal to what they give us here, m x n y t z. Now, what is m? We now say m, therefore m equal to m x. Now, you write this one first. You have the m x equal to m. The m here, put it here. The m put it here. This one, how many? You do see any power in it. You have raised power 1. This one cancel each other. It becomes s equal to what? 1. Now, what is l? And this l. L equal to y and what? L equal to 2. L cancel L, it becomes y equal to what? 2, the powers. T, the z, tz equal to what? T minus 2, minus 3. It becomes t cancel t, it become what? Z equal to minus 3. Therefore, our s equal to 1, our y equal to 2, our z equal to minus 3. That's how the way you can do this. Anytime they give you this, you must find the dimension, you now make it equal each other, you'll be able to solve the question. Most of the questions they normally come like this. And if you can able to get the dimension of anything that they give to you, you'll be able to tackle the question. Thank you so much. Make sure you subscribe to this channel and God bless you. See you in the next episode.